everyone, my name's Dia, and today I want to explain a crucial topic in physics and astronomy. What is angular momentum? The best way to describe angular momentum is with a quick recap of linear momentum. Linear momentum is basically just how much motion an object has while it's moving in a straight line. The harder an object is to stop, the more linear momentum it has. Now, angular momentum is very similar, except it measures how much motion something has while it's rotating. In an equation, it's written as the product of a system's moment of inertia and its rotational velocity. Moment of inertia is basically just how hard it is to stop an object from spinning or how hard it is to get an object to spin. It depends on the mass of an object and how the mass is distributed along the axis of rotation. Think of how easy it is to spin a pencil. It has very little mass, and all this mass is concentrated around its rotation axis, which is the center of the pencil. Now imagine trying to spin a dumbbell by holding on to that middle metal part. This would be much harder to rotate because the mass is much more spread out. Therefore, a dumbbell would have a higher moment of inertia than a pencil. The other component in the equation is angular velocity. Basically, how fast something is rotating or spinning. Now, what this is leading up to is a really key principle in angular momentum, which is that it's conserved. This means that if there are no external forces acting on a system, the total angular momentum for the system has to stay the same. Now, a good example of this conservation of angular momentum would be with a merry-go-round. Now, if you've done this before, you know that when you stand closer to the middle of a merry-go-round, you go a lot faster than if you're further from the center. But why? This is all due to angular momentum conservation, and let's discuss it. If you're at the edge of a merry-go-round, you are further from the axis of rotation. This means that the mass around the merry-go-round is spread further away from that axis of rotation. Now, if you recall, that means the total moment of inertia has increased. Remember, angular momentum is the product of the moment of inertia and angular velocity. So to account for this increase in the moment of inertia with you standing closer to the edge, your angular velocity would actually have to decrease in order to keep the total angular momentum constant. However, if you move closer towards the center of the merry-go-round, you would notice that something a little different happens. Now you're closer to the rotation axis, so the mass is less spread out and the moment of inertia would consequently decrease. In order to keep the total angular momentum constant, your angular velocity would increase and you would move a lot faster. Now I hope that helped in your understanding of angular momentum. It's a very useful concept in anything from star and planet formation to spinning a top, and that's its beauty.